Okay, our objective is to continue writing equations for linear functions in slope, intercept, and standard form. And then we also need to talk about, in more detail, rate of change today. What is it? How do you set it up? What else can we call it? So there is one other little concept that we need to talk about today, which definitely is very important in this chapter. Okay, first question I have for you, just very general, because this is very important. From yesterday, without looking, what is slope-intercept form? Jake? Good. Y equals mx plus b. In that form, when we go to identify x and y, how do we know what x is? Do you remember like that little trick I tried to tell you yesterday? How do we know what x is? John? Good. X is something you can't control. So most of the time, the x variable is going to deal with time. Month, hour, year, day. Anything that deals with time is usually x. Y is something that you can control, like miles, weight, food, candy, whatever it might be. It's something you can control. Okay? Any questions on any part of slope-intercept form? What's x, what's y? Okay, what is standard form without looking? Sage. Awesome. Okay, so there's standard form. Why do we have two forms? These are two forms that we use for linear functions. This one is primarily used for graphing and setting up word problems a lot. This form, yes, you need to know. You will use this form a lot in Algebra 2, little bit in geometry. But yes, you need to know two forms so you know you can set up linear functions two ways. Okay? In standard form, a and b cannot be what? This is really important. A and b cannot be what, Maggie? Or? Good. A and b cannot be a decimal. A and b cannot be a fraction. Decimals and fractions are the same thing. A cannot be what? Haley L. Good. You watched your video, right? Good job. A cannot be negative. A and b are not fractions or decimals. A cannot be negative. Okay? All right, let's start going over the homework. Number 6. I'm going to kind of read through this, and we're going to start one thing at a time. So Judy starts running today and is going to run 0.75 miles every day. This is page 4 in your notes. This is number 6. If you did not do your homework, please follow along as we do this. If you did something wrong, please fix it and make the adjustments that you need to. When we get to the table part with the fractions, I'm going to talk through that with you. That's my fault. I forgot to address that yesterday. On number 6, Zach, what is x? Good. X is days. What is y, Jackie? Good. X is days, y is miles. And you should also have on your paper, y depends on x, which is the same thing as saying the amount of miles depends on what day it is. X is always something you can't control. X is usually dealing with time, days, month, year. So think of that. Another thing that I want to say, Ms. Wingrove thought of this, and I think this is good for you, might help you. Anytime you have the keyword per, every, each, any of those keywords that means you're doing it on a routine basis, it's always the y, that keyword, and then x. I don't know, would that help? Kind of like y per x, y every day, y each day. Whenever you see those keywords, per, each, every, would that help you identify x and y? Give me a head nod this way or this way. All of you sleepy heads out there. Okay, maybe you just know it, but I want you to consider that. I will go through that again with our next example. It might be a shortcut in case you're getting confused. You don't have to use it, but something extra. Okay, slope-intercept form, Dirk, for number 6. Awesome. Can someone explain why is it plus 0? And I should have gave you a hint to this yesterday, and I forgot to do that with your class. But why is it plus 0, Heather? Good job. You just start running today. If you just start doing something today, you haven't ran any miles yet. If you just start collecting something today, you don't have anything yet because you're just starting it today. If you just start something today, this is always 0. Well. No. I put a box around this because this is what I want you to have. So what I put the box around, eventually, that's what I prefer that you have. Do not leave the equation with decimals. You need to make sure that you're typing into your calculator 0.75, hit math, enter, enter, or just do it mentally. If you know that 0.75 is 3/4, go for it. Any other questions for me on how to set this up? Okay, since I can't move this, let's do the table first since I messed that up with you guys yesterday, and then we'll go to standard form. So let me ask you this. Yes, 0 is a very easy value to use to plug in for this equation. Okay, decimals get on my nerves. I know they get on a lot of your nerves as well as fractions. What other value of x can we plug in for the table, plug it in here, so that we end up with a nice y value? So what other x value can we plug in so that it kind of gets rid of the fraction? No one knows? Well, 0 is one of them. What else? No one has any ideas? Did anyone use a value on your table and you got a nice answer? No? Okay. Amanda. Good. Why? Is 3. Good. If you plug in 4, if you look at the denominator of the fraction, whatever number that this goes into, so 4 goes into 4, that means these 4s are going to cancel. 3/4 times 4 is 3. Now, I did that mentally. You could put that in your calculator, put 3/4 in parentheses, and then type in times 4. If 4 works, what's another one? What's another factor of 4? Jackie? Good. 8. 8's another one, right? If you take 3/4 times 8, you get 6. If you write it out like this, maybe that makes more sense to you. 3 times 8 is 24. 4 times 1 is 4. 24 divided by 4 is 6. So now, did you have to do that? No. If you used 1, 2, 3, 4, any of those numbers, if you got a decimal, that is still correct in regards to graphing. So don't think it's wrong. I just think it might be easier to use nice numbers. In the other classes, all saw that yesterday. I just forgot to tell you that. Does that make sense? Give me a head nod this way or this way. Does that make sense? Okay. So here's the table I had up here, which is what we just talked through. Matt, what did you have for your standard form? Okay, but no decimals, no fractions. No decimals, no fractions. Okay, let me ask you this. How do you get rid of the fraction? So that 4. Good job. So at this point, Matt said negative 3/4 x plus y equals 0. You need to get rid of the fraction. I usually just multiply by the negative and by the denominator all at once. So if you distribute negative 4 to every single term, standard form for this one should be 3x minus 4y equals 0. Okay, I see like half of you writing. So what part of that did you miss? Maybe you realized what you did wrong. Is there something that you need me to go over again that's still confusing you? Positive? Matt, you okay on that? Okay. All right, any questions on 6 at all? Okay, number 7. John, what is x? Say that again? What word means x? What word means lunch? I just said it. What word means x? It's lunch. You have to say the word. Like, what does x mean in the problem? Oh, I thought you said 1. You said lunch. Sorry. Hey, what's y? You're good, John. Helene, what's y? Good job. The money. So here's another one where you could use y, and here's the word per or for x. So in this one, x is lunch, money is y. So you can always use your rate of change and do y per x. In this case, the key word is for. So money depends on lunches, x is the number of lunches, y is money. Okay, slope-intercept form, Sage, what did you have for 7? Okay, but you're spending money. So should it be plus 1.5 or minus 1.5? Good. So minus 1.5. And then negative 1.5, Sam, is what fraction? Good. So this needs to change to y equals negative 3 over 2x plus 12. Any questions on how to get the fraction or how to set that up? So it's negative because you're spending money. The 12 is positive because that's what you currently have, is $12. This is negative because you're spending $1.50 for lunch. Okay, what table values could we use to get rid of this fraction? So yes, 0 is one of them. What's another number we could use? Maggie? Good, 2. What's another number we could use for our table values? Jackie? Say that again. Good, 4. So if you use 0, 2, 4, 8, anything that 2 goes into will get rid of that fraction. If you don't like fractions, put them in parentheses in your calculator and hit times whatever you have to multiply it by. Any questions? Well, go ahead. Yes, yes. Y is money. If you wrote down cost of lunch or price of lunch, that's fine. That still means money. Okay. But whenever you labeled X and Y, did you label them as like the words? Okay, you can't say that. You could say lunch price depends on number of lunches. So be careful. X is something that you can control. Y usually, sorry, X you cannot, Y you usually can. And this one doesn't really follow because you can basically control both of those. Try to use the thing, Will, of Y for X or Y per X. I think that will eliminate that. Anyone else? Okay, standard form, Chastity. What did you get for 7 standard form? Good job. Awesome. 3x plus 2y equals 24. I have it right down here in this box. So on that one, you had to add 3 over 2x to both sides. And then to get rid of 3 over 2, multiply everything by 2. And that's how Chastity got 3x plus 2y equals 24. Questions on 7. Okay, number 8 I'm going to read through. Number 8, we have 1.25 inches every year. So we have y every x. Remember, there's your key word. So remember, you always have y per x, y every x. In this one, inches depends on year. X is year, y is inches. X is year, y is inches. Slope-intercept form is y equals 5/4 x plus 8. So I want to ask you this just to make sure you're following me. What table values could we use to make it a little bit easier for ourselves? In other words, to get rid of the fraction. Jackie, what's one of them? Good, 0. Jake, what's another one? Okay, thank you for being honest. So look at the bottom of the fraction. Besides 0, what else does 4 go into? Good, so 4. And then Amy, what's another one? Good, 8. So here's some table values. 0, 4, and 8 are the 3 that Miss Wingrove and I chose. I would pick those 2 if I were you, especially if you don't like getting decimals. And then standard form should be 5x minus 4y equals negative 32. This chapter has a lot of stuff in it, but this is the basic building block lesson of this chapter. So do you have any questions for me before we do one more of these together, Melissa? Okay, gotcha. So when you go from slope-intercept to standard form, you need to get this 5/4 x on the other side because standard form is ax plus by equals c. So to get this to the other side, you have to subtract it. You're still following the same rules as subtracting or solving an equation. So the opposite of addition is subtraction. You with me on how to move that? Subtract that from both sides. It cancels here, Melissa. So you're left with negative 5/4 x plus y equals 8. So now you got it. And then to get rid of the 4, because you can't have a fraction, And to get rid of the negative, because a cannot be negative, you have to multiply by the bottom of the fraction and a negative. So then this -4 gets distributed. Remember that from yesterday? Okay. You all right? Anyone else? Okay, let's go to number 3. So go back to page 3, flip backwards, and I forget where I put it. Take a look at number 3. Okay, number 3, I want to do one more of these with you before I start to talk about rate of change for a little bit. Okay, so Mary owes $20 on her credit card bill and charges $5 to it each week. $5 to it each week. I want you to think of this as she is spending money. You're charging it on your credit card, even though that money is not out of your pocket yet. Think of that as she is paying for something. She's getting rid of her money, okay? So let's start here. What is X and what is Y? Keaton, did you get a pink packet? Pink packets are back there. Go ahead and get a pink packet, please. What is X and what is Y? I want you guys to tell me without me giving you a hint. Amanda, what do you think X is? Okay. Money or bill, however you want to think of it, depends on week. So Amanda gave us that very first part. She's correct. So the pink one, Miss Winger will show you. So here's something. If you have Y each X, money, and then week. So week is X in this one, and Y is money. Or you could say bill, total bill, amount charged. Doesn't have to be exactly like what I have. And again, you could use a little shortcut. It's always Y, and then that keyword each, per, every, and then X. Okay, slope-intercept form is Y equals mx plus b. All right, what do you think? What is slope-intercept form for this equation? You're thinking of it as she is spending money. Sam? Close. She's spending money. You're getting closer. She's spending money. So what about that 5? If she's charging $5 every week, that means she's spending, good job. She's spending $5 every week. Now, what Sam initially said, I would still mark that right on a test. If you think of this as 5x plus 20, which means she is adding money to her credit card bill, I can understand that method. But I want you for now to think of it as she's spending money. If you're spending money, it's going to be negative because you're getting rid of your money, right? You're spending it. So negative 5x minus 20. They either both need to be negative or both need to be positive. Okay, let's go to standard form. So let's rewrite slope-intercept, which is y equals negative 5x minus 20. Reno, how do we put that in standard form? Good job. Add 5x to both sides. So Haley L., what is standard form going to be? Good job. 5x plus y equals negative 20. This one was a little bit easier than the fraction ones. Okay, let's pick 3 values here. That's not a fraction, so it doesn't matter. I'm just going to pick 0, 1, and 2. At week 0, how much money has she charged? Or how much money has she spent, Will? Good, so negative 20. At week 1, how much money has she spent? Or how much money is on her credit card bill? Amanda? Good, 25 or negative 25. And then at week 2, you should all have your hands up because all you're doing is plugging 2 in for x. Sam, how much money? Good job, negative 30. Any questions on that? You're going to do more of these in class today and for homework, so sure you don't have any questions? Okay, flip over for a couple minutes to page 5 in your notes. I just want to introduce this to you. Okay, page 5, which is part of this lesson, but it's a little bit different than setting up the equations from the scenarios. Starts off with components of a linear function. They already typed for you. A linear function has three different components. It has a slope, it has a y-intercept, and it has an x-intercept. We are going to talk about all of these in this chapter, one at a time. Just an overview, just like we did for parabolas, there are three different components of a linear function. Okay? I need you to write down that slope. The definition of slope is the rate of change between one quantity over another quantity. So slope is the rate of change between one quantity over another quantity. I also want you to put in parentheses, no decimals, no mixed numbers. So slope is the rate of change. I also want you to put in parentheses, no decimals, no mixed numbers. Like I tried to mention yesterday, when you're graphing and it's a decimal, it's going to be much more, I think, annoying and difficult to move up 0.25 and then over 1. It's much easier to change 0.25 to 1/4 or whatever the decimal may be so that you can go up a nice number, over a nice number. And I'm sure you remember part of that from graphing last year. You want your slope to be a fraction. One more thing I need you to add either above or below that box is what Miss Wingrove thought of that might help you. I want you to write down under or above, rate of change, y per x. Rate of change. I want you to think of it as y per x, and we'll see if this helps. So you could also say like y each x or y every x. Any of those key words that mean per. So any of them. I'm just putting one up there because I don't have enough room to write all of them. All right, you ready to, we're just going to try a couple of these. You ready? These can be, for some reason the 7th grade class had a tough time with these, so, and last year 9th grade as well had a tough time with these. So let's see how you guys do. Okay, the first one. This is the same scenario that we talked about yesterday with writing equations in slope-intercept standard form. But now we are focusing on what is the rate of change. Okay, so let me read it again. Michael has run 3 miles this week, and he runs 2 miles every day. What is the rate of change? Anyone know before I give you a hint? Melissa. Good job. 2 miles every day. The rate of change is what is changing. You're doing something every day, every week, every month. It's what is changing. The rate of change. I want you to write, this is this key word, which means per, every, each. Put a y every x. I want you to write that underneath. I had you write that for the definition just to help you try to remember this. I think that might be something that really helps. And we know x is day, y is miles. The rate of change is 2 miles every day. We need to write that as a slope. It's always going to be, I'll tell you this now, it's always going to be y over x. Does anyone know how we would write it as a slope? Do you remember from last year? If it's always y over x, well, what would we do? Good job. 2 miles over 1 day. Same thing as what Will said, 2 over 1. Now, Will, I added in, you said 2 over 1, I added in 2 miles and then the 1 day. Because that's what it means. It's always y over x. We'll get into more detail later. 2 miles over 1 day and then 2 over 1. That's all for rate of change. Give me a thumbs up, thumbs down on that problem, just so I can see how much time I need to spend on the next one. So give me a head nod. Is this easier than what we did yesterday? Some of you. Okay. Any questions? Okay, let's go to number 2. Number 2, Jen weighs 200 pounds and loses 3 pounds every week. Someone that hasn't answered in a while or answered yet. What is the rate of change? Katron. Awesome. loses 3 pounds every week. I'm going to put negative 3 pounds every week. Now, you could put loses instead of the negative if you want, but I'm going to keep the negative in front just to make it easier for our slope. The rate of change, what is changing? She is losing 3 pounds every week. All right, I want to put my little y and x underneath it. Where does the y goes underneath what and the x goes underneath what? Jake. Awesome. So it's always, here's our keyword, which means per, every, each, whatever that might be. It's always the y, that keyword, x. Okay. What is the slope? It's always the y over the x. Amanda. Awesome. Negative 3 pounds over 1 week. Zach, what is just the number slope without the words? Good. Negative 3 over 1. For now, both of them. Yes. And for now, you have to have both of them written down. Okay. Let's do 3, and then we're going to go to 5. So number 3. Mary owes $20 for her credit card bill and charges $5 to it each week. What is the rate of change? Zach. Good. $5, so I'm going to put a negative because you're charging it, which means you're spending money, so it's negative. $5 each week. Okay, John, I need to put my y and x underneath them. Where does the y go? Where does the x go? Oh, hold on, you're ahead of me. Where does the x go and where does the y go? Good. Good. So remember, it's always y, your keyword, each, per, every, and then x. Okay? Now let's go to slope. With the number and the words. Maggie, what's the slope? Good. Negative $5 over 1 week. And then Matthew, without the words, what is the slope? Good job. Will, question? The 20 is the y-intercept, and we didn't talk about that yet. Just like in this one, the 200 is her initial weight. That's the y-intercept. We didn't talk about that yet. Good question. Did you guys notice anything? The slope here, whenever we wrote our equation, it was y equals negative 5x minus 20. Your slope is always next to what in an equation? What is the slope always next to? What is the slope always next to? Look at that equation that I just wrote. That's what we wrote when we set up our scenario. How is the slope related to this? Well, you just said that wrong. Not next to the y-intercept. I mean, technically, it's next to the y-intercept, but it's right next to what? Right, it's right next to that x. So the slope in your equations, we'll spend more time with that tomorrow, is always next to x. Do you remember that from last year? Guess not. Okay, don't worry about that. Let's go to number 5. I want to do one more of these, then you're going to start homework. Okay, number 5. Emily has $15 and loses 25 cents every day. Chastity, what is the rate of change? Good. Loses, or negative 0.25 cents every day. Amy, where does the x and where does the y go on this one? Remember, it's always y per x. Any of those keywords that means per, every, each. That's the order it goes. Is the money, and x is day. Okay, be careful on that. Helene, what is the slope with numbers and words? Good job. Okay, now we need to fix this. Before we keep going, we need to write this as a fraction. So what are we changing that to with the numbers and the words? Jake? Awesome. So is it -1 cent or -1 what? You know what I'm saying? So what are you changing it to? -1 what? So let me do this. Maybe this will help, not just you, but anyone. -1 what over 4 days? Well, how do you know that, Sage? Good. So if you lose a quarter for 4 days, somehow, I don't know why you lose quarters every day. If you lose that for 4 days, that's $1. You've lost $1 in 4 days. So anyways, change the decimal to a fraction always, just like we did yesterday. And then your last step is just to write the slope as a number. Your slope is -1/4. Okay, I know this is a lot of stuff. Any questions for me? Okay, I have 2 things to pass out for you. Miss Winger, I'm just going to need your help if you don't mind. Your homework, and I just need to change this, you're not doing all of this, is only 1 to 4 on the rate of change worksheet, and on the 4-2 worksheet, thank you, you're going to do the whole thing, because that's what we did yesterday and today. Please don't lose these worksheets. This is just something that I should have put in your homework packet, but did not have it done yet. So put your name on each of these, and then I will explain what each of them are. And they are organized for you, so you really don't have to write anything out in regards to tables or any of the lines. Okay, and ideally, I'm going to walk around and help you. It'd be nice to have more time. Okay, if you don't mind, just put it up here, Jake. Okay, let me start with this. Make sure you all have the worksheet that says practice with linear functions and slope. Underneath it, it says lesson 4.2. So you're going to do the back and front of this. This is just like what we did yesterday and today. But what I did, guys, is I set up, I made a table for you. So put your slope-intercept form where it says 2. Make sure your slope is not a decimal. Put your table where it says to put the table. And then put standard form where it says to put standard form. If you need to look back in your notes, that's why you take notes. Feel free to do that. If you need to go on Blackboard and watch a video again, do that. There is a back and front to that worksheet, okay? The other worksheet, which says rate of change at the top, is what we did just today. Do the same thing we did in the notes, but don't leave the slope as a decimal. Any questions for me? Okay, you have 7 minutes. You should get a good amount of this done. So get started. I will walk around. If you are confused with making a table with fractions, I would start with the 4.2 worksheet, number 1. And I'll come around and help you if need be.